absolute value. This time, the absolute value is going to be an inequality and not an equation. So let's see if we can kind of come up with some sort of rule that would help us to understand this. Let's think about a number that I could put in for x here. What's a number that I could take the absolute value of and it would be less than 3? 2 would work. 1 would work. 2.5 would work. 2.7 would work. 0 would work. The absolute value of 0 is 0, and 0 is less than 3. Are there any other numbers that would work? For instance, -1. What's the absolute value of -1? 1. 1 is less than 3, so -1 would work. So -2, absolute value of -2 is 2, 2 is less than 3. What about -2.5? What's the absolute value of -2.5? It's 2.5, which is less than 3. Notice this group of numbers that I've got. How could we categorize or summarize this group of numbers? We could say this group of numbers is less than 3, but it's also bigger than -3, because -3 is really our stopping point and 3 is our stopping point. So when I say the absolute value of x is less than 3, I'm talking about all the numbers that are between -3 and 3. So anytime I have the absolute value of something is less than something else, I can say that the group of numbers that work for x have to be smaller than 5, but bigger than -5, because it's going to be all the ones in between. So if you think about how then that you would graph that, here all the numbers between 5 and -5 would be the shaded ones in between. So when we have a less than equation, it's going to be shaded between those two numbers. So let's do the absolute value of x is less than 7. Since I'm talking about all the ones that are less than 7, we know that those numbers are going to be less than 7, but bigger than -7. So if I graph this one, I'm going to go from -7 to 7. These both have to be open circles because they're not equal to, and then I shade in between. Let's try this one. Absolute value of 2x plus 1 is less than 5. This time I know that whatever works for 2x plus 1 has to be smaller than 5, but bigger than -5. So this one's a little different because we have an expression inside of here and not just x. So I've got to go ahead and solve. I'm going to take 1 away from each part. So I'll get -6 is less than 2x is less than 4 because I subtracted 1 from each part. And then go through and divide everything by 2. So -3 is less than x is less than 2. So all the numbers that would work for x in my inequality are going to go from 2 to -3, and they're going to be the numbers in between. And it's open circles again because I don't have a line drawn underneath. Let's do one more here for less than. Let's do the absolute value of -x plus 5 is less than or equal to, let's make it 6 this time. So since this is a less than, and a lot of students remember since it's pointing towards the absolute value bars, I know that my answer is going to be somewhere between 6 and -6. And then I've got this expression in between. So now to solve, I'm going to subtract 5 from each part. I have -11 is less than or equal to -x, less than or equal to 1. Now, I don't want -x, I want positive x, so I've got to divide everything by -1, so this goes to +11, -1, positive x. And because I divided by a negative, I have to reverse the symbol. So now, my solutions for x are going to be between -1 and 11, and all the numbers in between, and then close dots because it's less than or equal to. Let's just pick a number in here and see if it works. 2 would be inside of here. The opposite of 2 is -2. -2 plus 5 is 3. The absolute value of 3 is less than 6. So everything inside here that we've shaded should actually work in that equation.